So I'm going to present the status and news about Open Modelica development and applications. I got some help from Adrian Popp and Peter Fritzen, and there will also be two shorter presentations by Lennart Ochel and Massimo Ceraulo at the end of this session. This is the overview, so I have no idea who you are. Maybe you already know Open Modelica and you want to know what's new, or maybe you tried it a few years ago, you were badly disappointed and you want to see if it's now gotten better, or maybe you just never heard about it, so this is all brand new stuff for you. I try to make something, to come up with something that is good for everybody. So we'll briefly cover what is Open Modelica, quickly present our GUI, our integrated development environment with graphical user interface. Some words about release planning and what happened with the latest releases, ongoing work, and then a bit of discussion about the benefits of using an open source Modelica tool. Currently, Open Modelica is the only one that has this attribute, and also explain a little bit what is the open source Modelica Consortium and what can it do for you. Last but not least, I will briefly introduce a couple of interesting industrial uses of Open Modelica, talk a bit about future developments, and then I will hand the presentation over to Lennart that will show a demo of OM Simulator, which is our open source FMI SSP simulation tool. This is rather new, so maybe you're not familiar with it. And finally, my colleague Massimo Ceraulo from University of Pisa will talk briefly about his experience teaching hybrid and electrical vehicles using Open Modelica. Massimo is an early adopter of Open Modelica and an enthusiast user, both himself and his students, so I'm sure he will appreciate that. And finally, we will have time for some questions and answers. Okay, so what are we trying to achieve with Open Modelica? Our goal is to release a comprehensive modeling, simulation, and systems engineering environment that can be used for research, for teaching, and for industrial usage. We want it to be open source, both for academic usage, where maybe that is more commonplace, but also for industrial applications. We'll see later on why this can be advantageous. We want to foster and encourage open source cooperation around Open Modelica, both regarding tools and applications. We'll see some examples. And through the years, we are increasing the emphasis on industrial usage. Open Modelica started many years ago as a mostly academic tool, but now we're really focusing on let's say, real life tough use. The Open Modelica open source environment is actually a fairly large collection of several tools. I'm not even going to present all of them because that would probably take most of our time. At the bottom of the stack, we have the core Open Modelica compiler, or OMC for short. This is a full-fledged open source compiler supporting Modelica 3.5 language fully, I would say, and also equipped with Python, Julia, and MATLAB scripting interfaces, so you can interact with the compiler either from the command line or from all of these scripting environments through APIs. We have an integrated development environment with the graphical user interface to develop models with drag and drop metaphor and for simulation. This is named OMEdit. We'll see that in a minute. Since a couple of years, we're also developing OM Simulator, which is at the core a standalone FMI SSP simulation and co-simulation tool, which, however, has also a graphical user interface integrated in OMEdit. Lennart will talk about it later. And we also have some, let's say, more bare bones text-based environments, share environment, an OM notebook that can combine text, interactive, simple Modelica simulations and graphs. I am actually using this for teaching and find it very useful. And an Eclipse environment development, which is currently mostly used for compiler development rather than for actual modeling and simulation. there's actually much more. You can look at the online users guide and discover what you can find within the package. I would spend a couple of minutes on OMEdit. This is our flagship tool. It looks similar to other tools such as Daimola or SimulationX that have a graphical user interface. Here, this maybe we can have a short demo in a minute, but just to show you a few quick highlights. You have the standard features for these tools, a graphical library browser that can allow you to allows you to explore packages and open models. You can do graphical drag and drop editing of models. You can run simulations. You can see the results of simulations using the variable browser and selecting the simulations, the actual variables that you're interested into. You can browse the embedded documentation in the model, which can be shown in the library itself, in the tool itself. And also we have some advanced feature that I will present better in a minute in a short live demo, which is the integrated debugging environment. I think this is something rather unique. I'm not aware that other tools provide something like this, so maybe I will spend a few minutes with that. Let me try to see if I can show you a quick demo. Sharing the screen normally bogs down the machine quite a bit, so I hope that works. So this is how the environment looks like. Here we have opened the Modelica standard library. You can open and explore what you find around. Of course, you can check the graphical view of models, or you can check the textual view, zoom in, zoom out, and stuff like that. There's parameter editing with tabbed environments in case the library is designed with that in mind. And yeah, you can either simulate existing models, maybe change their parameters, or build something from scratch. Those of you who have attended the tutorial yesterday will have seen this already. And then when you're ready, you can just start the simulation. This translates the model in memory, produces some C code. The C code is compiled. This takes a few seconds, or maybe like 10 or 15 seconds for more complicated models like these multi-body systems. And then when the code is ready, it is run in the background. And if everything goes fine, then you have a full-fledged, sorry, let me move this around. Yeah, demo. Demo with screen sharing is always dangerous. Too bad. I tried this 1 minute ago without the screen sharing. It was working fine. Anyway, what you would have seen at this point is exactly what I'm showing you here. While the thing hopefully gets running again, I wanted just to show you a minor improvement that we have applied recently. As you can see here, if we zoom in a bit, instead of getting not so nice, yeah, now it's working again. So this is the results that you get. If you zoom in here, this is meters, in fact, and if you're zooming, you can get the results in millimeters. Well, that depends, of course, on how well. Yeah, for example, in this case, the graphical representation is automatically adjusted, so you get automatically the right units, so millimeters or kilometers or micrometers or millikelvins or whatever, which can be convenient. You can also, in the case of multi-body systems, you can also run animations. This has been available for a while. I hope that works and it doesn't hang with screen sharing again. So now here you can run these animations, turn stuff around. So yeah, this has been already featured for a while, but for those of you who are not familiar with the environment, that's, let's say, standard functionality that we've been offering for a while. What is not so standard, as I was mentioning, is the debugger. Let me show that to you briefly. I'm not sure if this thing here is. Let me try to. Okay, so as you may know, there is a lot going on in Modelica tools. So you start from an object-oriented composite model, which is equivalent to a bunch of differential algebraic equations. And then these are subject to a lot of symbolic processing. They are solved symbolically, sorted, lots of stuff is going on until they get to the form, which is very close to the solver, and that's the stuff that actually runs when you run the simulation. This debugger actually shows you what happens. So for example, here you can see one by one all the operations that are done during assignment. You see them with initial, and then you can also see what happens during each time step. So you see here again many variables can be computed by assignments because the tool has been good enough to actually solve them symbolically. If you double click on top of one of them, you can actually get more information. For example, well, yeah, this is a parameter. It's not particularly interesting. Let me check something maybe. Yeah, this is mostly graphical stuff. Yeah, here for example. Yeah, so these are equations related to the physics. So you can get information about how they have been solved on this bottom right window. You can actually get some. Yeah, sorry, this is very slow because of screen sharing. You can get the full symbolic chain of symbolic manipulation and actually a link to the original line in the source code where the solved equation is coming from. Here you have a list of variables. You can filter them. For example, if you look for R0, you can find the variables on the frames. And if you double click on one of them, you will see in which equations are these variables computed or assigned, and in which equations they are used. So you get really an insight of what is going on. This is very, very useful in case something goes wrong and you need to debug a model. Last but not least, you can also get nice execution statistics. So for each of these solved equations, you know how many times this is called during a simulation and how much time it takes and what is the percentage to the total. So for example, if you order this by the fraction, you can understand what are the equations or the system of equations. In some cases, you may have systems of equations, nonlinear ones solved by iterating or stuff like that. And you can actually figure out what are the bottlenecks of your simulation. If there's something going wrong, maybe, or the simulation is very slow, you can try to figure out why. Maybe there's some discontinuity or something. I think this is a really cool feature that OpenModelica has been providing for a while, and I really wanted to show that to you. Okay, I guess we have to continue with the regular slides, otherwise time is running short. I hope I can get back control of my presentation, hopefully. Yeah, I guess I need to stop sharing and start again because doing all of these things with screen sharing is really dangerous. Sorry about that. Okay, sorry. I knew that the demo could have been a bit dangerous, but I really wanted to show you something live. So, since a few years, OpenModelica moved to a time-based release plan. In the past, we were trying to have releases when some features were developed, but this was really causing lots of delays. So now we have regularly 2 releases per year. In one immediately after the Christmas break, and the other one immediately after the summer break, with some beta testing in between. We often release maintenance versions in between these releases if there are critical fixes. There's nightly builds available that you can download every day with the latest cool features. Of course, they could actually be broken, while, let's say, the official releases are subject to a beta testing process, so they are supposed to be stable because there's a lot more testing. And in some cases, we also release stable versions in between the official versions by freezing nightly builds that look pretty stable, so that we can get cool new features available to users in advance before the official release that is maybe coming in a few months. Lots of interesting things have happened since, let's say, the last conference in the last couple of years. The new compiler front-end has completely replaced the old one by default. It's fully supporting Modelica 3.5 and up to 20 times faster, flattening the models compared to the old one. This also helps getting OMEdit to work much faster than before, because OMEdit relies on the compiler to get all the information about the models. The front-end now can flatten 100% of the Modelica standard library, both the old version 3.2.3 and the new version 4.0. And it can also flatten 100% of many other Modelica libraries that we're testing daily. Here you can see a partial list. We have improved the symbolic manipulation and the runtime features. For example, we have now an algorithm developed by Karim Abdelhak that is very good at detecting hidden constraints in high-index systems, such as 3-phase AC circuits, and making sure that index reduction can be applied. We now have full support of homotopy operator. We included recently new solvers from the Sandels suite, the IDA solver, and all the CBOD suite of OD solvers. We switched to CLang instead of GCC also on Windows, which makes the compilation much faster, so that the time it takes from when you click simulate to when you get the results was shortened considerably. Also on Windows, because we switched to dynamic linking of libraries by default. You can still have static if you want, and that also accelerates the compilation phase. You probably have noticed that if you use OpenModelica with the latest reviews, with the latest releases. The GUI has been improved in terms of responsiveness to user inputs. We now have the possibility to select replaceable classes with drop-down menus. Unfortunately, it's still not possible to change parameters of the redeclared classes. This is coming soon. We have some cool features like the automatic selection of appropriate unit prefixes, as I showed you, or toggling the sign of variables, so you can compare variables which are almost the opposite of one another. It's small things, but they can come in handy. We also improved the handling of large and high resolution screens, which was a bit shaky in the past. And the GUI both supports the standard library 3.2.3 and 4.0 based on the uses annotation. So your library or your models just declare which Modelica version they need to use, and it gets loaded automatically when you load them first. We have now this OM simulator, FMI SSP2. There will be a presentation afterwards, so I'm not spending too much time on this now. we are continuing the development of FMI 2.0 export. We now have FMI model exchange export with efficient analytic Jacobian computation, which speeds up the simulation, improves numerical robustness. As to co-simulation export, we can now have both embedded Euler, which was the default until a couple of years ago, but also CDO solvers, including implicit stiff ones. And this is great if you want to have basically royalty-free FMU generation, because whatever code you generate, you can use where you want, and there are no limitations. We have an open source Modelica package manager that can handle the automatic download of packages that are available on public repositories based on the uses and notations of your libraries. Currently, this package has a textual interface. The plan is to have it integrated into GUI in a future release. And last but not least, Open Modelica now also supports encrypted libraries through the use of Modelon's open source license manager. This feature requires specially compiled binaries, and these are only available to consortium members. I'll get back to that in a minute. So why using an open source tool? Well, obviously, you pay no license costs. This is what everybody understands. Open Modelica is released under GPL v3, so you can just use it, and there's no cost for doing that. This also is interesting because it allows you to deploy Modelica libraries and Modelica models at customers or partners' sites or colleagues with no additional costs. And this is true even if you're using other Modelica tools for development, as long as the code is really standard Modelica. Maybe you can develop it with another tool, but then you can distribute it and have other people run it, maybe by changing parameters using Open Modelica with no extra cost. You get royalty-free generated simulation code in the form of FMUs, for example. This, for example, makes it possible to devise infrastructures where you have massively parallel simulation on the cloud. Say you want to run a huge parameter sweep study with 10,000 simulations. You can buy some computing power on the cloud and deploy this code on 100 parallel CPUs for a couple of hours and get it done very quickly without worrying about licenses. A very important point for me is that there's no trade secrets on all employed algorithms and methods. The algorithms and methods that are used inside Open Modelica are mostly published. And even if they're not published, the source code is available with all the details on GitHub. This also allows a cooperative approach in resolving problems and implementing new features and capabilities. If you have some problem that is challenging from a numerical point of view, you can actually work together with the developers and without, there's no secrets. This already allowed several interesting success stories. One is the data reconciliation functionality that was developed in partnership with EDF. This is an extension of standard Modelica semantics. Basically, you start from an existing model of a power plant or a section of a power plant. You have measurements, uncertainty, data, and you can put everything together and try to get the best possible estimate for the parameters and let's say the most precise estimation of variable values given a priori knowledge and some assessment of uncertainty and measurements. This was a feature that is very important for EDF daily operation. It was developed together with them, and it's now available, including a GUI in the last release version. Yeah, regarding no secrets, we have published a paper on an open access journal. You can get this freely from the internet. It's a fairly long paper that basically contains pointers. It explains everything which is going on behind the scenes with references and links to dozens other papers. So this is a nice, let's say, guide that will guide you through whatever is happening behind the scenes. And let's say, compared to commercial tools where you just get commercial brochures, here you also get all the, let's say, the dirty details in full display. I think this is also interesting added value. couple of quick words about the open source Modelica Consortium. We're already a bit late because of the demo hiccups. Sorry about that. The consortium has been established some years ago. It's the consortium that promotes the development of the open Modelica tools, both by employing some core developers that work on it full time, but also by coordinating development activity by consortium members, which are mostly either working because they are commercial entities, or because they are funded to do research if they are research institutes or universities. The consortium owns the code, so that the code is owned by this non-profit organization, and it is released under dual license, so either as GPL, which is open source, or with a closed source license that allows consortium member to customize the source code and redistribute it to their customers or partners without the limitations to the GPL free release. It provides assistance and support to members, and it currently includes 24 companies and 24 universities. You find more information at this link. The consortium is growing, and you're welcome. You and your organizations are welcome to join it. Instructions how to do so are found in this page. The consortium can provide you some basic software support, including with a membership. It can help you porting your Modelica libraries to Open Modelica, where porting basically means, on one hand, making sure that they are really written according to the standard, and on the other hand, if there are issues with Open Modelica, we identify them and see how to fix them. It also allows you to use modified Open Modelica source code without GPL v3 in industrial products. And then you can also have targeted development of features with contracts which are specifically addressed to do that, or contracts for maintenance support that give you high priority support compared to the standard support that you get with membership. And in general, foster and encourage open source cooperation around tools and applications, as you already said. These are some of the contacts that you can that you can go to if you're interested. Just a couple of quick words. We have some of these development contracts of general interest going on. One is a strategic partnership with LBL Labs that is developing the buildings library as a part of the spawn of Energy Plus initiative, which is aiming at replacing the Energy Plus tool for building simulation with a new Modelica-based infrastructure. The common goal is to enable long-term full open source, the capability to have a full open source Modelica-based building simulation. Currently, we are aiming at getting full support of the buildings library by the end of this year. This would be a big deal because buildings contains pretty much everything you could do in Modelica. There's thermal systems, hydraulic, electrical, thermal, you name it. So achieving full coverage of this library would also mean that most other libraries will have much improved support. And in the following years, we're planning to focus on improving compilation and simulation speed for large size building simulation models. We also have a strategic partnership with RTE, the French transmission system operator. Here, the long-term goal is to enable fully open source modeling and simulation of power grid models at national and even European scale. That's the long term. For the next 1.5 years, the objective is to improve Open Modelica capabilities in terms of optimized code generation, use of efficient sparse solvers, which are essential in this area, and DA mode, where basically you use one solver both for algebraic loops and for differential equations, efficient handling of events, and all the technical details that are required to run these models efficiently. I guess I have to skip these 2 slides because time is running short. So just a quick overview of what we are planning to do. In the short term, we will have, hopefully by the end of this year, but I won't promise anything to you today. We are aiming at having integrated package manager and conversion scripts in OMEdit, full support of replaceable classes, including editing parameters, and in general, faster and more responsive OMEdit GUI by exploiting the new frontend. We also want to provide missing features in OMEdit, such as a smart duplicate of models, hierarchical parameter editing for models that have many levels, and so on. In general, we're aiming at achieving 100% coverage of major open source available Modelica libraries that you're testing every day, and also improve quality of FMI export. In the medium long term, we are working on a vectorized backend and code generation infrastructure for efficient compilation of large-scale models. This is a strategic goal for us. We should also manage to get a unified C++ simulation runtime. Currently, we have many, and it's a little bit of a nightmare to develop all of them and keep them up to date. And last but not least, we are evaluating if and how to port the whole Open Modelica code base into Julia. There's been presentations yesterday by John Tinnerholm regarding this. This would be interesting because it may allow to leverage on the growing base of Julia libraries that provide numerical and symbolic handling, and also, let's say, becoming part of a larger community, which would further accelerate the development of Open Modelica. That's all I wanted to say on my part. So I'm now going to play a short video by Lennart that will give you a very quick introduction to OM Simulator. I hope I can get it to full screen. And of course, the problem is that if I try to play it, there's no audio. I tried it before getting into this call and it worked fine. But now, Elena, do you have any suggestion for that?
Do you want to play a video?
Yes, I tried it before and it worked fine, but now that I am sharing the screen and everything, the audio is inaudible. And I have no idea how to get the audio of the video into the feed. Maybe in the meantime, I can hand it over to Massimo so he can have his own presentation, and then maybe you can try to play this video for me at the end. Okay?
Yeah, we can do so.
Thank you very much. So Massimo, if you want, the floor is yours. I guess you need to turn on your video or screen and your microphone, otherwise we can't hear you.
Massimo, can you hear us?
Okay. Probably now everything should work now.
Now we see your screen.
Okay. Thank you for your for this opportunity, Francesco. I just want to show you my experience in using Open Modelica for teaching. And I teach here in Pisa electric and hybrid vehicles. And these are systems which take advantage of Modelica language capability a lot because it contains so many subsystems from different fields of engineering. And also I want, whenever possible as a university teacher, to use open source tools because we should try to be neutral with students, not to support one commercial company or another, because teaching with using one commercial piece of software means giving future money to that company. So that's tricky. I prefer whenever something good is available to use open source tools. So I decided to use Modelica many years ago. In the very beginning, at 2010, Open Modelica was not mature yet. So I started with Daimola. Since 2014, I chose some hybrid solution with diagonal and OpenModelica, but since 2019, I just use OpenModelica because it has reached a good level of stableness, reliability, and power. And also, I tried to make my students feel part of the process. So if they find some bug, they can report. They can even get additional marks if they are able to make well-repeatable and acceptable bug reports. So this changes their attitude. Instead of being mad of difficulties or being upset, they try to be active and react to them and make bug reports. And they have done this several times. So mainly based on teaching experience, myself and my colleagues have posted many bug reports. The majority of them were solved, and we also contributed to discussion on the internet with the OpenModelica. So what I teach is vehicles, electric vehicles and hybrid vehicles. I try to, typical with my student, I compare vehicles with the body of a person, because a body has everything inside it. A body can live, can move, can travel. And also a vehicle should have everything. It has a mechanical structure, which can be compared to the skeleton, supports the vehicle. Powertrain, which can be compared to muscles, so uses energy to move and doing some labor. And also we have the control system, because power is nothing without control, which compares to the nervous system. So as a body of a person, which must be able to do everything for living, also a vehicle has everything, and it is the perfect test bed for Modelica applications. Mainly in my course, I teach powertrain and the control for powertrains. So number 2 and number 3. And even though I limit to number 2 and number 3, I have multi-engineering systems to teach, which can take advantage of Modelica. So this is an electric vehicle in my concept. The driver commands everything. It has accelerator and brake. Here is the electric drive, an inverter and a machine, the reduction gear, the wheel, and then the vehicle mass and the resistance to movement. So the drag force due to friction in the air. So we have in this system an electric part, a rotational mechanical part, a translational mechanical part, and a control. Specialized tools are not so good at dealing a system with so many interconnected parts. Also, this model is published on GitHub following the open source concept. I don't have my camera. Oh. This is another example. This is a hybrid vehicle, so more complex, much more complex than an electric one. And here the nice thing is that we have so many signals going from the physical components to the brain, which is an electronic control unit. And here we have a bus, pretty much the same. It happens in real vehicles. So we can imagine inside these lines several signals going from sensors to the brain, and from the brain, the electronic control unit, to the actuators. But instead of having many lines here, and also in vehicles, instead of having many physical lines, we have buses. So digital signals can flow in the same channel simultaneously. And this is also a cool feature of Modelica and OpenModelica. Naturally, for teaching, in this case, I could present students this architecture, and they build this manually themselves. They make the connections, they choose the parameters, find any mistakes they have done, and they succeed in creating by themselves. In other situations like this one, it is impossible for a teacher to let them understand, let them to build so complex models, but I give them, if this model is given to them, then they can change, for instance, efficiencies, masses, reduction ratios, and they resimulate more and more and more and see the effects of their variations on a good, rather sophisticated series hybrid model. And okay, so they are able to experiment. This is like a virtual experiment on board a hybrid vehicle. This again another hybrid vehicle. This is a series hybrid. We have again the energy management system, the electronic control unit. It's the same in this case, and this also has a logic on-off signal to the genset. So the control system of the vehicle not only requires some power from the genset, from the engine in the series hybrid vehicle, but also can, this is on-off, so it can command when to switch it off and switch it on, like occurs in the real life series hybrid vehicles. Also, this is just proposed to students, and they can make changes, efficiencies, masses, and so on, changes on the parameters to see the effects of the changes. But these models are used for simulations lasting tens of minutes. So they are not so detailed. We can go further in detail, zooming inside, for instance, the electric drive and model this drive a bit more with more details and look at shapes. But this is still not very detailed. We can go even in more detail with inverter, the detail of an inverter with switches which switch on and off, look at the shapes, the distortion of the shapes, and analyze. So we can go at different levels of detail, time detail, and performance details, all related to the same system. From time to time, we need to do something more, some post-processing, but following the open source idea, we can very, very easily export comma separated value CSV files, and then they can be imported in another tool. I created this and I put this on the GitHub, and also it's available to everyone. Here we can do sums, algebraic sums of variables. For instance, we can make integrals of powers to get energies. We can make the combination, any kind of algebraic combination of variables, or find the Fourier spectra of signals, because this is not yet available in OpenModelica, but electric engineers need very often to have spectra. So Fourier analysis can be very, very easily done using the comma separated value export of files. So I'm a bit far, near to the end. I just have 1 minute or two more. Very recently, Elon Musk published the curve of Tesla Plaid, which is this one, and it is the red one. These are HPs, so more than 1,000 HPs, which makes our students enthusiastic. And the nice thing is that this is also very near to the ideal, much more than the previous Tesla cars, performance and other cars. This one is very near to the ideal one. We also have the numerical parameter thanks to some reverse engineering made by inside EVs. We put these parameters in our model, and we can check the performance. And even though the model is very simple, even though the parameters come from an internet site which has made just some reverse engineering, the results are very, very near to what are published by Tesla. But now we have a model where we can do whatever we want. We can try to see what happens in positive slope, downhill, uphill, acceleration, braking. We have a model. We have the parameters. We have validated the model through the published data, and we can do whatever we want. Okay, so OpenModelica has improved dramatically over the last 6-8 years. I saw improvements in speed, model coverage, GUI. Now, OpenModelica is adequate for teaching and research. For teaching, it covers all models of reasonable complexity. Speed is compatible with classroom lessons. GUI has improved. The good surprise is that teaching models can be used for research and contracts. So I used teaching models for contracts. I carried out paid contracts with minor variations of teaching models. More sophisticated features are a bit harder to use. For instance, we have dynamic optimization, which Daimler has not, and we use this for research. I didn't have time to explain this capability. Also, Francesco didn't mention this because it is a bit tricky, but once we get accustomed, it works and works well. Finally, it's also very good for us, the FMU support, which is improved very much in recent months. We have contributed to the discussion on this, and I posted tickets on this, and I had fast response and corrections to issues. So my teaching experiences were very good, and I thank you very much for your attention here. In case of questions, obviously, I'm available to answer.